Good morning, everybody in the room. Good morning, everybody joining us by live stream. Welcome. So as Charlie said, my name's Jeremy. That's my website, adactio.com. It's awesome. I'd like you to visit my website. In fact, I'd like you to visit my website right now, and preferably on your phones. I see some of you got your phones out. I'm going to make it easier for you, save you having to type 11 characters. Here's a QR code. On Android or iOS, you should be able to point your camera at the QR code and go to a URL. Normally, this is the point where I'd say the people at the back might need to pinch zoom to get that QR code. I don't think that's going to be a problem in this room. So, is that working? Are you being taken to a URL? Yes? Okay, good. Good. I've tricked you into going to my website. Now, this is going to be part of a demo later on. Rather than me doing the live demo, I'm getting you all to do the demo for me. There's another website I'd like you to go to, and this time the URL really is quite long, so you almost certainly want to use the QR code, resilientwebdesign.com. So point your cameras at that. It should then pop open a browser tab with resilientwebdesign.com in it. Feel free to look around that website. It's awesome. It actually, I say website. Technically, it's a book. It's a book that's online. It's a free book. You can read the whole book online. And when I say free, I mean free, not like you have to give me your email address. It's actually free. I'm not tracking you or anything like that. Well, we're going to come back to that later. But this is not the first book I ever wrote, which is surprising because I distinctly remember after writing a book for the first time saying, I'm never going to do that again. But here we are. The first time I ever wrote a book was back in 2005. I'm showing my age here. And it was a book called DOM Scripting. I don't suppose anyone's ever read that book. Wow. Okay, also showing your age. Oh. And it was a book about JavaScript in 2005. What's funny is that the gist of what I was saying in 2005 was, you should use JavaScript, it's really cool, and not enough people are using JavaScript. Which again, ironic, because these days I'd be much more likely to be saying, people, enough with the JavaScript already, right? But back then, it's hard to imagine a time when you would have to convince people to use JavaScript, but it's true. It was kind of, this nasty, buggy language that was responsible for pop-up windows and making things not very pleasant. But there was a potential there, right, with JavaScript. It could change expectations about what a website could do. And that has enormous implications then for the user experience, right? So those sort of early uses of JavaScript, there were use cases like this. This was a really common one when JavaScript came on the scene in the late 90s was, all right, when someone mouses over a link, we're going to change how it looks, right? So mouse overs, image rollovers. Anyone remember like Dreamweaver and the JavaScript __ stuff it would spit out? Basically to do this, when someone mouses over a link, make it look different. Or when someone's filling out a form, make sure that all the inputs are valid, right? Does that email address really look like an email address? Have they filled in the required fields? And these are good uses of JavaScript. What's really interesting with these use cases, these ones and ones like it, is that these days you wouldn't even use JavaScript for this stuff, right? For the mouse overs, you'd use CSS. You'd use :hover, which didn't exist at the time. And for form validation or making sure required fields have been filled in, you'd use the HTML5 input types and the required attribute, which again didn't exist at the time. So it's almost like in JavaScript we figure out what it is we want to do, and then over time the really popular common things kind of make their way further down into the declarative layers like HTML and CSS. But when you look at these sort of use cases and you squint at them just right, you see that they kind of got something in common. They're basically following a pattern. And the pattern is this: find stuff and do stuff to it. All right? Find something on this document and then maybe add an event listener, do something to it. Now this phrase, find stuff and do stuff to it, this was the motto, the mantra, if you will, of the jQuery project. which came along sort of late 2000s. Literally find stuff, do stuff to it. And what jQuery did was it gave us a new idiom in JavaScript to do these very common tasks. So in jQuery, you might write it like this. You know, you had the $sign was short for jQuery. Find something in this document, and then add an event listener to do something. Now, the genius bit of jQuery's design was that the find stuff part of this used CSS selectors. So if you already knew how to write CSS selectors, you were halfway to writing the JavaScript already. That was brilliant. And of course, these days, we don't need to use jQuery because we can use JavaScript itself using query selector all, right? Add event listener. Now, the reason we have query selector and query selector all in JavaScript is because of jQuery. jQuery, again, sort of proved that there's a real need for this, and it got codified into the standards. I think it's a really good example, actually, of what a good library or a good framework should aim to do. And that is, a good library should aim to make itself redundant. That it's that useful, it ends up going, down into the standards layers, much like we had happen with those early uses of JavaScript. So what's interesting here, though, is what I'm actually trying to do is the same in both cases. I'm trying to find stuff and do stuff to it. But what we have here is that logic is translated in two different ways. One into jQuery's idiom, and the other into vanilla JavaScript, as we'd call it these days. So what we're looking at here is we're looking at the logic, find stuff, do stuff to it, and we're looking at the code, which represents that logic. So really, I would say that code is an act of translation. You've got to first of all figure out what it is you want to do, and then you translate that logic into code. And having been doing this for a while, I've formed a hypothesis that seems to be bearing out over the years, which is that I think that the logic is more important than the code. The logic's more important than the code. And I say that because I will be showing code in this presentation, but if you can't follow it or it's bad code, because it probably will be because I wrote it, don't worry about it, because I will also be showing logic, and that's the bit that really matters. The code is translation. The logic is more important than the code. So after writing this book, DOM Scripting, in 2005, and swearing I would never write another book again, 2 years later I wrote another book. This was about Ajax. Ajax is one of those funny buzzwords. I mean, it was huge at the time. We don't really use anymore. But it's not that we don't use it because we stopped using the technology. It's quite the opposite. Again, the technology became so ubiquitous that it seems silly to have a separate word for it, right? Because Ajax is about, updating part of the page without refreshing the whole page. It's like, well, that's just using JavaScript these days, right? But Ajax, that wasn't, from a technological point of view, it was groundbreaking that you didn't have to have a full page refresh to get data from the server. And again, that had huge implications for the user experience in terms of what we could build and how things on the web could feel. And that's why, I was excited about it, because I saw that Ajax had the potential to change expectations, just like JavaScript did back in the 90s, change expectations about what the web was capable of. And what Ajax is, I guess, is simply updating the page, right? So the logic is update part of this page with data from the server. And the technical details of whether that's JSON or XML or even chunks of HTML doesn't really matter, but this has huge user experience implications. So that's different from all the other JavaScript we had before, right? When we're doing stuff to the DOM, we were saying find stuff on this page and do stuff to it, right? Now we're saying update part of this page with data from the server. That was the new part. Still, you'll spot what these two things have in common. We're still talking about using JavaScript to deal with stuff on this page. The page that's currently loaded in the browser window, we're manipulating it somehow, either with plain old DOM scripting or using the new fancy Ajax. It's all to do with this page. And that was the state of things in JavaScript land for a long time. And the problem with that is that if you're using JavaScript to manipulate the stuff that's in this page that's currently loaded in the browser, you're on the same processing thread as everything else that's doing stuff to that page, like painting things to the screen, making sure the scrolling is supposed to be smooth, right? So if your JavaScript gets too complicated, too computationally expensive, that can have effects on things like the user simply being able to scroll, right? You've all felt those janky websites, right, where the JavaScript is just trying to do too much, and the result is everything just starts to feel kind of nasty. That's because it's all happening on the same thread, because it's all dealing with stuff in this page. So a few years back, we got a new kind of script called a web worker. And a web worker is able to run on a separate thread. So it can't interfere with scrolling or anything like that. Great. The price you pay is that what you do in that web worker, you write normal JavaScript, but you cannot access the page open in the browser tab. You don't have any access to the DOM. You can't do any of that stuff. So it's kind of a trade-off. You can communicate with the page with kind of messages, but you can't do any of the normal find stuff and do stuff to it when you're writing this web worker. It's kind of like this separate thread, does things asynchronously. It won't slow down the current page, but you don't get to have access to the current page either. So when I heard about web workers, and I thought, this is interesting. What's a good use case for web workers? It's for doing computationally expensive tasks off the main thread. And I remembered a website I'd seen, gosh, in the late 90s, early 2000s, and I realized this is the perfect application of a web worker. And that website was the prime number shitting bear. To explain, it's a bear that shits prime numbers. Now, I distinctly remember, if you left this open in your browser window, over time, as those prime numbers started to get bigger and bigger, the fan kicks in, your machine starts to slow down. If you rewrote the prime number shitting bear with a web worker, you could be crunching prime numbers all you want, and your browser is going to be just fine with that because it's on a separate thread. So web workers, very interesting addition to JavaScript. And then we got a new kind of web worker called the service worker. So again, like a web worker, it's on a different thread. You don't get to have access to what's in the current page that the user's looking at, but you can do all sorts of asynchronous stuff. And it kind of opens up access to some APIs. And again, I started to get very excited about the potential here and how this could change expectations of what's possible on the web, how it could change the user experience. And I went ahead and ended up writing another book called Going Offline, which the very astute of you will notice is the same title as this very talk. So again, the reason I'm excited about service workers is because just like Ajax beforehand or JavaScript in the old days, it has that potential to really change expectations that people have about what the web is capable of. Now, so writing this book, the first task was explain what a service worker is. And it's not easy, I gotta say, because they're weird. Okay, it's a kind of web worker. It's sitting off the main thread, fine. But then it's kind of like it can intercept network requests, right? It's kind of a programmable network proxy. Doesn't really tell me that much. I mean, the best explanation I've been able to come up with is that it's like a man-in-the-middle attack on your own website. But like in a good way, right? A virus that you control. I'm going to resort to diagrams to try and explain service workers. All right, we've got a client, we got a server. Server is serving example.com. The way the web works is we send a request from the client to the server. Aha, but it doesn't go straight to the server, does it? No, it's got to navigate that whole great big world, network in between. So it has to traverse the network, which might mean going half the way around the world, and then that request hits the server. Then the server sends a response back to the client, but not straight back to the client because it's got to go halfway around the world before it finally ends up back in the client. So that request might have been for a web page. And then in that web page, there might be script elements, style elements, links and images. And every single one of those is going to kick off another request to the server, traversing the network every single time, right? Scripts, styles, images, all that stuff. Well, in amongst all that stuff that this web page might be requesting is a certain kind of file, and that's a service worker script. So the service worker script is sitting on the server. Something in your web page says, all right, grab me that service worker script. The request goes out, finally hits the server after traversing the network. The service worker script is sent back, but this time it's not, injected into the page. It's not used by the current page. Instead, it's kind of installed onto the device. Installation is a good way of thinking about this. And once it's installed, it then kind of sits between the device and the network and is capable of intercepting requests and doing, well, whatever you want it to do. Because it's a script, and you write instructions to say what you want to happen with those requests. One thing I should point out, I've been saying, this is example.com is the domain on the server. To be more specific, for this to work, it would have to be https example.com. Because given the fact that this is a man-in-the-middle attack on your own website, it is vital that it's done over a secure connection. So service workers only work on HTTPS. There's an exception for local host. If you're developing locally, that's fine. But this is definitely something that has to run on HTTPS. And anyway, there's many reasons why you want to be on HTTPS, not just to get access to APIs, but make life more difficult for the NSA and GCHQ. That's got to be a good thing. So what I've just described there is kind of this life cycle of this service worker script. It's sitting on the server to begin with, and then these things happen. And you register the service worker. You say, hey, I want to put that on this device. Then it gets installed onto the device. When it's installed, it's then active and listening to these kind of requests. There's one other part, which is updates. What if I change my service worker on the server? So it's possible that you want to replace the service worker that's installed. So here's how that life cycle looks. Register is when I say, go get me that service worker. Install is when the service worker is sent from the server onto the device. After the install event, now it's active and in listening. Now, update will happen if you just change one single character in the service worker script on your server. The browser is going to check to see if it's different, and it'll update that service worker. The way that updates work is exactly the same way that your browser updates work. Now that we've got these evergreen browsers, right? The new version will be downloaded in the background, and it's sitting there in the background waiting to take over. The old one is still in charge now, as long as the user is browsing your site. As soon as the user leaves your site and the service worker powers down, the old one fades away, and the new one takes over, and now the new one is in charge and is active. So exactly like the way that your browser does updates. Downloads in the background, just waits for you to close your browser, and then updates automatically. So let's take a look at that life cycle. Let's take a look at this register event where I'm saying, I want that service worker, please. What's the logic I'm using here for register? Put it basic, I'm going to say, get the JavaScript file serviceworker.js. All right. That's my logic. Now I need to translate it into code. Well, I know how to get JavaScript files. I do this all the time. I point to external JavaScript files. I say, script source equals, and then there's my JavaScript file. Don't do this. This is what you do when you want to request a JavaScript file from the server to interact with the current page, right? To do regular JavaScript or Ajax or any of that stuff. When it's a service worker, remember, it's not about what's in the current page. So there's a different way of asking for those files, and it's using this service worker object, navigator.serviceworker, and this method called register. You pass in the name of the file. So here I am saying navigator.serviceworker.register serviceworker.js. And that's how you tell the browser, I want you to fetch that service worker file. Now, you might be thinking, well, right, it's a JavaScript file, and I keep my JavaScript files in a folder called JS, in another folder called assets, right? You might have a folder for CSS, a folder for images. So you think, right, better update my URL, so I'm pointing to assets/JS/service worker. Don't do that. Yes, it's written in JavaScript, but I think because service workers are so different from the regular kind of JavaScript you use to interact with the page, it's better to think of service workers as more like, well, they happen to be written in JavaScript, but treat them differently to your normal JavaScript files. Because if you do this, the service worker will be able to listen for requests and all that, but only for requests going to assets/ .js. So the scope of that service worker, what it's able to listen for and control, is determined by where the service worker sits. So almost always what you'll actually want to do is put it at the root level of your site, so it's got control over the site. So this is the way you register a service worker and say, I want to install that service worker. I would go a little further than this, though. There's a big assumption baked into this code, which is that the browser understands navigator.service worker. That's not necessarily the case. So for older browsers, not many left that don't support service workers at this point, but still, I always try and do feature detection in any JavaScript I'm writing. So I'll just check, say to the browser, do you understand what this is before we go ahead and use it. Note, this is feature detection, not browser detection. I'm not saying, are you Chrome, are you Firefox, right? Browser detection is terrible, don't do it. Feature detection is when you just ask, do you understand this feature? If you do, great, execute it. If a browser doesn't understand what that is, that code inside the curly braces is never going to get executed. All right, so I bulletproofed it a bit, but this is now the code equivalent of this logic, get the JavaScript file service worker.js. Though technically, what I'm really saying isn't get the JavaScript file, I want to do something with it. It's install the JavaScript file service worker.js. And install is what happens next. The file's been sent from the server, and now it gets installed onto the browser. Now, an event is triggered when a service worker starts to install itself. And that's really handy, because we can listen for that event and do some stuff before the service worker becomes active, sort of pre-prepare. And one of the things you could do is around caching. The install event is perfect for this. Now, when it comes to caching in the browser, there's a couple of different ways we've been able to cache in the past. First of all, there's the memory cache. This is the most short-term cache. This is, if you have a web page, and early on in the web page, there's an image, right, with a certain URL. The browser fetches that image from the server. And then later in the same web page, you have an image with the same URL. The browser does not go and fetch it all over again. It knows it's got it already for this page. That's the memory cache, very short term. The more common cache we're all familiar with is the browser cache. And this is one cache that's shared between all the websites you ever visit, right? And this is where we send headers from the server saying, please cache images for a long time, but please don't cache HTML, and please cache CSS for a long time, unless I change the CSS, right? So it's this shared resource. It gets cleaned up occasionally, right? This garbage collection happens. This is the way we've done caching on the web for the longest time. I mean, just step back. What caching actually is, if you think about it, it's storage, right? It's file storage. I'm putting a copy of something over here. But it's different to storage in the sense of something like backup, right? When I back up my hard drive, I'm putting a copy of something over here, but my hope is, I hope I'll never need that backup, right? In the cache, it's almost the opposite way around. I'm putting something here, close to me, because I'm pretty sure I'm going to need it again, right? So you cache things because you want them to be available for quick retrieval. It's almost like the opposite of backup, where you hope you'll never need it. So browser cache is what we've used for this for many years, but now we have a whole new way of doing it with more control, and that's the cache API. Browsers have literally opened up the inner workings of how they did the browser cache and exposed it to us. And we can now make our own caches that are for our domains only, that aren't shared. It isn't a shared thing. You can make as many caches as you want. You get access to a lot of space. And you can store things there because you think, I'm going to need that very soon. So one of the things you can do with the cache API is during the install event, you can do what's called pre-caching, a phrase that really bugs me because, as I've just explained, the whole point of caching is that I'm going to need it later. So what's the point of putting pre in front of it? It's like a tautology. You know when you're reading a recipe and it says preheat the oven? Like, don't they mean heat the oven? Right? What's the point of putting pre in front of it? It's a given that you're going to need it for something. You can't post-heat an oven, right? Step 4, violate the laws of thermodynamics. Sorry, it bugs me. But pre-caching is the term people are using for this, so we'll stick with it. The idea that during the install event, you grab a bunch of files and you put them into a cache because you're going to need them later. So here's how that would work. While the service worker is installing, that triggers the event, we say, oh, hey, I want you to fetch a bunch of files on the server, right? Grab them. But now instead of putting them, using them on the current page, instead of that, we're going to create a cache and put those files into the cache so that we can use them later, nice and close to hand. And then we can avoid using the network for those files. So that's pre-caching, and it happens during the install event. So here's the logic of pre-caching. When this service worker is installing, open a cache, and then put a bunch of files in that cache. Okay? When the service worker is installing, open a cache, and then put a bunch of files in that cache. Let's translate this into code. When the service worker is installing. Now I've got a little sort of trigger here, which is that whenever I see the word when in my logic, I can be pretty sure that that's going to translate to add event listener. We're talking about events. And sure enough, in this case, there's an event that's triggered when the service worker is installing. It's imaginatively titled install. So what that means is I can say, when this event happens, I'm going to execute some code. I'm going to have a function, an anonymous function here that executes something. And by the way, the nice thing with service workers is because it's supported in modern browsers, if you want to use modern JavaScript, ES, whatever we're calling it, then you can do it. You don't have to transpile, you don't have to run it through Babel or anything. So if you like, you can use the nice arrow syntax for functions, which I kind of like because it looks like ASCII art coding, right? I'm literally passing this event into this block of code. Or not. It's completely up to you. It's purely stylistic. What really matters is the logic, because the logic is more important than the code. Okay, so I'm listening for that event when the service worker is installing. Inside those curly braces is the code I want to write here, which is open a cache. So this is that API I was mentioning, the caches API, and it has a method called open. And this is how you open a cache. It takes one argument. That is the name of the cache. Again, very imaginatively, I'm going to call it files. But you can call your cache anything you want. You could call your cache Johnny, and then it would be Johnny Cache. Moving on. The next step, and the reason why I've made this a separate step is because it maps so nicely into translation. I literally say .then, right? And this is a pattern you'll see over and over again with these kind of APIs where they're asynchronous. Remember, the crucial thing about a service worker is you don't have access to the page. You can use all these APIs in a service worker, but everything has to be asynchronous. If it's an asynchronous API, you can use it in the service worker. If it's synchronous, you can't use it. And caches API is asynchronous. And it follows this kind of pattern, right? You do something and then you have .then for what you want to happen when it's good and ready. So once that cache is open, I can write some more code. So I'm passing the reference to that cache into another chunk of code, which is where I have the final bit of my logic, put a bunch of files into that cache. And there's a method called add all. It takes an array, and I can literally give it a list of files I want to pre-cache. So that's what I'm doing here. My style sheet, my script, some images, right? I've put those files in there. One thing to note, if you're doing this, if you're using add all, make sure that all those files do resolve, the URLs do resolve, because if there's one 404 in there, none of the files are going to get cached. So, I've translated my logic into code. When this service worker is installing, open a cache, and then put a bunch of files in that cache. The service worker is installing, open a cache, and then put a bunch of files in that cache. There it is in plain English. Here it is in JavaScript. When this service worker is installing, open a cache, and then put a bunch of files into that cache. All right, so now we've got a cache with a bunch of files in it that we can use. So how might we use this cache? We've got a kind of primed cache ready to go. Well, at this point, the service worker is installed, and it becomes active. And now we have access to that cache as well as the network. And now we have the power to decide how we want to use that cache. Well, there's all different kinds of strategies, different sort of recipes you could use with this power. Here's one, cache first. What if we avoid the network for certain requests and go straight to the cache. Now, a demo is on its way, but just really quickly, let's just run through the logic of what you're about to experience. I'm saying when a file is requested, try to find the file in the cache first, and otherwise, fetch that file from the network. So cache first, network second. That's the priority here. All right, let's translate this logic. When a file is requested, there's that word again. When? It's an event. We're listening for an event, and in this case, it's the fetch event. A fetch event is triggered every time the user requests a page, every time that page requests a style sheet, every time that page requests an image, a script. Every single time, that's firing a fetch event. And you can listen to each one of those fetch events and do something with it. You then get to write some code to intercept that request. Maybe you want to send back something different to what was requested, right? So you are effectively responding to the request, and this is how that looks. Event.respond with. So how do we want to respond to this event? Well, our logic says we want to try to find the file that's being requested in the cache first. There's a really handy method of the caches API called match. With this syntax, you don't even have to specify which cache you're looking in. Just look, do I have this file anywhere in any of my caches? Pass in the URL that we've intercepted. And if that's worked, then we're going to send that back. So we return the response we got from the cache. If it's not in the cache, then it's time for the final bit of our logic, which is otherwise fetch the file from the network. We say, okay, if you don't find a response, fetch it. So that's what the double bars is. Or fetch that file from the network. So there we go. When a file is requested, try to find the file in the cache first. Otherwise, fetch the file from the network. When a file is requested, try to find the file in the cache first. Otherwise, fetch the file from the network. That's the kind of cache first method. So request goes out. Service worker says, try to find the file in the cache first. And if it does, great, we respond. And we haven't even hit the network. We avoided the network completely. So that's super speedy, right? What if you did this for everything? Like if you pre-cached everything and you always went to the cache, you would effectively be offline first. The network is no longer necessary. The server is no longer necessary. Offline first. Sounds kind of wild. Let's see it in action. So I asked you to go to this URL earlier. I hope you either have it still open in a tab. If not, there's that QR code again. Now I would like you to go offline. So swipe up or however you do it and go into airplane mode. I don't need to tell you how to use your own phones. I'm sure you've done this many times before. And then go back to that web page. Actually, on iOS, you'll probably get an annoying notification saying, oh my God, you're offline. Well, it's okay, iOS, it's okay. You can dismiss that with okay. And then, fingers crossed, start browsing around resilientwebdesign.com. Particularly, like, go to a URL you didn't go to earlier. You know, go to something deep in there, scroll around, take a look. You should be able to navigate around the site even without a network connection. Is that working for people? No? Okay, yes, it's working. Brilliant. Flawlessly. First time. Sorry if it's not working for anybody, it's probably your fault. No, I don't. Okay, so at this point I should say, you can go back online now. I don't want you getting the twitches because like you're disconnected from the world. So feel free to go back online. But hopefully you've seen that this is offline first. Now, this is pretty extreme, offline first for literally everything. But in this case, it's a book, and I have no plans to ever revisit the content. Maybe I'll fix the occasional typo or something, but it's fairly static. So it makes sense in this case, but probably not for everything. So the way it's working is I'm pre-caching during the install event, and I'm pre-caching everything, all the pages, images, all that stuff. And then I'm using a cache-first strategy when the service worker is active, saying go to the cache first and only go to the network as a last resort. Now, that might seem pretty extreme for a whole website. And like I said, a book is a good example where you could do it, but Most websites, you actually want the HTML to be fresh. But you can apply this strategy for things other than HTML. So for your CSS and your JavaScript and your icons and all that kind of stuff, this is actually a really good strategy. Pre-cache that stuff during the install event, and then when the service worker is active, always try looking in that cache before going out to the network for the speed, performance benefits. Now for your HTML, you probably want to flip that around. You probably want to say, look at the network first because the freshness of the HTML is really important. But even here, you could have a fallback. You could say, well, suppose we don't get a response. Maybe the user is offline or our server is down. In either case, we could say, here's a fallback. Show a custom offline page, right? Something to tell the user they're offline. So this is a network-first strategy with a kind of fallback of an offline page. We say, go out to the network first, try and retrieve that HTML page. If that fails, then grab this custom offline page out of the cache and put it up there. Now, to do that, we need to make sure it's in the cache. So I'm revisiting the pre-cache logic we had earlier. Remember, put these files in the cache. I'll just add one more file in there, and that's this custom offline page. So this is like, in the recipe shows where it's like, here's one I made earlier, right? You have your offline page sitting there in the cache. The network first strategy is like this, and this is the final bit of code I'm going to show. After this, no more code. Before the code, the logic, because the logic is more important than the code. When a page is requested, try to fetch the page from the network first, otherwise retrieve the offline page from the cache. And we know it's in there because we put it there during the install event, right? All right, when a page is requested, there it is again, when. Sure enough, it's the fetch event. We're listening for fetch event. A bit more specific this time. It's not just when a file is requested. It's when a page is requested. So how do we tell it's a page? Well, there's different ways of doing it. Here's how I tend to do it. I look at the headers, see, is this an HTML page? Don't worry about it. I know it's nasty, it's ugly. Don't worry about it. Basically, there's a way of translating page here to say, is this a request for a page? If it is a page, then we want to try and fetch it from the network first. So we want to respond with a fetch from the network. So we're fetching the page, and then if we get a response, we return it. So I mentioned this pattern you'll see over and over again with asynchronous APIs. The fetch is an asynchronous API. You do the fetch, and then you go then. So when the fetch resolves, here's what I want to have happen. Return the offline page, or return that page. If it doesn't work, we have a corresponding catch. This is what I want to have happen in the case of it not working. I want to retrieve the offline page from the cache. So this is how I do that. I do that caches.match again, this time point at an offline page, which we put in there during the install event. So I'm saying, when a page is requested, try to fetch the page from the network first. Otherwise, retrieve the offline page from the cache. Getting a bit more complicated, but that's it for code now. I'm done showing code. So this can be really handy to just have an offline page. I mean, if nothing else, just for branding reasons. Instead of showing a dinosaur or whatever the browser shows by default, you get to show something with your own branding, your own colors, your own typefaces. Like in the same way you might do a custom 404 page, now you can do a custom offline page. Here's an example for an event we ran in Brighton last year, ampersand, a web typography conference. And if you're offline, you try to visit the website after visiting it at least once, you just get this offline page. Sorry, you're offline. But then it has the minimum information you're going to need for the event, where it is, what time does it start, right? Not many details, just like the minimum you might need to know. So you could imagine doing this for a restaurant website. You could have a custom offline page just said, here's the address, here's the opening hours. I mean, I would really like it if restaurant websites did that for their online pages as well. And you can have fun with this. Trivago do this. They've got a service worker, and it's all search based on Trivago, so there's not much you can do if you're offline. So they give you a game to play, right? You're offline, play the offline maze puzzle. It's pretty neat. So for HTML, you probably want to try this strategy. Go to the network first, otherwise fall back to a custom offline page. We can go deeper. Why does it have to be just a choice between two things? Why can't we say, well, try the network first, and if that doesn't work, try the cache. If that doesn't work, try the custom offline page. And this is possible if you use this cache as you go strategy. So this is the case that every time we're getting something from the network, why don't we keep a copy. Put it in the cache. So the more someone browses around your website, the bigger the cache is. It's getting filled up with the stuff. And then you end up with this priority list. Network, cache, fallback page. So cache as you go, I'm not going to translate this into code, I'm just going to run through the logic, is when a page is requested, just like before, try to fetch the page from the network first, just like before, but now we introduce a new step. Store a copy of that page in the cache, and then otherwise try to retrieve the page from the cache, and finally show an offline page. Now we've got those 3 levels, network, and if we do get a response from the network, keep a copy in the cache. Second choice, cache. Third choice, offline. Let's see it in action. I asked you to visit adactio.com earlier. Hopefully you've still got a tab open. If not, there's the QR code. Browse around the website first, right, before going offline. Try visiting a couple of URLs, maybe some journal entries or some articles. And then once you've visited a few sites, because this is the caching as you go part, then let's go offline. So swipe up from the bottom, go into airplane mode, freak out iOS. So, oh my God, you're offline. Tell iOS it's okay that I'm offline. And then try browsing around the site some more. Now, as long as you revisit a page that you've already visited before, you shouldn't even notice that you're offline. You should just be served that page from the cache. It's only when you try to visit a page you haven't visited do you get my custom offline page, which says, I'm sorry, there's no network connection. But on that custom offline page, I can now rifle through that cache and go, yeah, you're offline, but here's a bunch of stuff you can read even while you're offline, because these are all the things that you cached as you went. Right? These were all put in the cache. So in this case, I'm using the cache API from the offline page. There's no service worker involved at this point. It's the offline page is using the cache API. So the offline page is getting that information out of the cache and listing it on the offline page without using the service worker. So this is kind of a nice strategy I've used in a few different places. ClearLeft is the agency I founded in Brighton. And if you browse around the site but then lose your internet connection, you get shown the pages you've already visited and you can revisit them. There's an Irish music community website I run. Same pattern. Sorry, you're offline, but here are the things you've looked at recently. So, starting to see you could have different strategies for different kinds of files. For your CSS and your JavaScript and your images, you could absolutely use a cache-first strategy. Go to the cache first, only go to the network as a last resort. Whereas for your HTML, you might want to say network first, cache as you go, so that you can try the cache as a second option, and then finally have some kind of fallback, like an offline page. So what we've got here are different priorities, depending on the kind of content. And Service Worker gives you that kind of fine-grained control. I want you to do this, I want you to do that. So the priority difference here is, for HTML, I'm prioritizing freshness over speed. Whereas for those assets, I'm prioritizing speed over freshness. And for different websites, you might want to slice it differently, depending how far do you want to go. For games, in-browser games, not multiplayer games, you could totally go offline first. Once it's downloaded, it's all in JavaScript anyway. You don't need to go to the network anymore. You could use offline first. You could use that cache-first strategy even for the HTML. Well, for a shopping website, you probably want to prioritize freshness, right? You want to say, here are the latest products and so on. But even so, you could have that custom offline page. In fact, when you're browsing around Amazon and it says recently viewed items, that's perfect use case for the offline page, right? Yeah, you're offline, but you can still revisit these items you looked at. For some kind of reference thing, maybe we're talking like a Wikipedia or documentation, something like that, you could probably go offline first, but maybe combined with cache as you go. So by default, you're getting it out of the cache, but then you could get updated versions while that's happening. Travel website, probably want it to be fresh, but again, the custom offline page could have the minimum viable content. So when you're in the back of the taxi trying to get to the airport, trying to look up your itinerary, it's like, sorry, you're offline, but here's the minimum bit of information you need to know. Articles on blogs. This is an interesting one. How important is it that it be fresh? If it's latest breaking news, it probably does need to be super fresh. But if it's an old blog post, maybe not. you can definitely use cache on demand for this kind of content, I think, where if you visited it once, you get the cache version, but only if you've requested it. So this is a really nice recipe, strategy, I think, because it kind of puts control into the user's hands. The logic is, when you're on a page, you have a button on that page, you say, when the user presses this button, put a copy of this page into the cache. Cache as you go. So there's no service worker involved here. This is actually just like good old-fashioned DOM scripting. You say, when a user presses a button on this page, store a copy of this page in the cache. You can see this on Una's website. For any of our articles, it's got that icon up there, that interface element that you can click to save for offline. And now it's saved for offline. This is like having Instapaper or Pocket, but specifically for your own website. Sarah Swadan has the same pattern. You know, maybe it's a long article, you don't have time to read it now, but you want to read it when you're on the plane, you want to read it when you're on the subway. Hit that button, now the page is saved for offline. I've used this on a website, the Deconstruct Archive, archive.deconstruct.org, and this is for conference talks, the audio of conference talks from a conference we put on for 10 years straight. So it's like all the archival recordings that when you're browsing around, you can save for offline, but it's not just the page you're saving, it's the audio file as well. So that then when you're offline, you say, sorry, you're offline, but here are the things you specifically requested to save for offline. And effectively, it's a podcast player now that you can listen to on an airplane or wherever. So there's so much power in your hands. If you have a website that's running HTTPS, and you then add a service worker to it, you can do all of this stuff. And if you've gone to the trouble of doing these things, having HTTPS, having a service worker, even if it's just to show an offline page, I would add one more element in here, which is go ahead and add a web app manifest file. And the good news is this is by far the easiest of these three steps because it's a JSON file. You link to it from a link element in your HTML, say rel equals manifest. You point to a JSON file, which is key value pairs. And it's basically metadata. It's the kind of meta crap that we used to fill up our heads of our document with. Now we can put it into an external file with, like, here are the icons that can be used. Here's the home page, right? Here's the color scheme. And this is all information that can then be used for when you add it to your home screen. So feel free to do this with this website, Resilient Web Design. You might have it still open in a tab. If not, there's the QR code. On iOS, it's a real pain to add to home screen. You have to hit that icon and choose add to home screen. And then all that information is now coming from that web app manifest file, gets installed on your home screen. And now it behaves pretty much like a native app. When you open it from the home screen, it behaves just like a native app. You'll notice the browser Chrome is gone. That's because I said display standalone, display like your native app. And the experience is very similar to a native app. If you're on Android, did anybody get this showing up? Okay, right. So you're prompted to install it. This is basically Android rewarding these kind of sites. They're running HTTPS, they have a service worker, they have a web app manifest. Well done you, we're going to prompt the user to install it. Now, those people who put their hands up saying they saw this banner, how many of you immediately dismissed that banner? Okay, so this is why I'm not sure this is a great interface solution to this, because we, the web development community, we spent years training people to dismiss things that pop up when you load a page. Well done us. Well done us. You probably thought I was asking you to subscribe to my newsletter or accept cookies. So no, this was actually coming from the browser, nothing to do with me. In fact, you can't even force this. This has got to come from the browser. The only way to get it is if you have a web app manifest, your site's running HTTPS, and you have a service worker, which means, you know what you got? You got yourself a progressive web app. I'm sure you've heard this phrase, progressive web app. You've tried to understand what the hell is a progressive web app. You've read some Medium articles and you're none the wiser. This is what a progressive web app is. It's a web app manifest on a site running HTTPS that has a service worker. It's not a state of mind. It's not about native-like experiences. It's testable things. And you can actually test these in tools like Lighthouse and stuff. It is concrete technical things. So I think this is great. And a lot of people really fixate on the web app part and think, oh, well, this isn't for me because I'm a publishing house. I'm not making a web app, so this progressive web app stuff isn't for me. Nonsense. You can use it for any kind of website because the important bit isn't the web app. The important bit is the progressive. that we can take our existing sites, you don't have to make something new, take your existing sites and elevate them. HTTPS, a service worker, a web app manifest. And then people can install them just like native apps. And now websites can provide equivalent experiences to native apps. The challenge here is not technical. The challenge is not technical. The challenge is about expectations. The people don't expect websites to behave as well as native apps. People don't expect websites to work offline. Now, how do we change that? One website at a time. And that's why I hope that you will consider designing an offline experience for your site. And then if we all do that, we'll have something better than a collection of progressive web apps. We'll have a progressive web. Dank u wel.
That was amazing, wasn't it? I particularly enjoyed the Johnny Cash thing.
Fantastic.
Yeah. So we're running slightly late because we started late. So we've got time for one question, I think. And I think there was a question about, is there a size limit to these?
Yeah, so I mentioned that the shared browser cache is shared by every website and it gets cleaned up occasionally. Your cache made through the Cache API won't be cleaned up in that same way, but it would eventually be cleaned up, and the ultimate power lies in the hands of the user. As to how much storage space you get in that cache, a lot. We're talking like megabytes and megabytes. For each browser, it varies slightly. I know from Firefox, it's a certain percentage of available space. For Safari, it's similar, but Safari also expired the caches based on engagement. So if the user visits the site within, I think it's something like 30 days, you're all fine, but if past that, the browser might clean it up. So it varies from browser to browser, but it's not small. It's a lot of stuff, which means you have to be responsible for cleaning up those caches and not making them too big. I know I put an entire book into your cache, right? You might be thinking that was a bit cheeky, but I justify that in that the entire book is still less than one page on Wired.com or The Verge.
Cool, fantastic. Once again, let's get a big round of applause for Jeremy. Woo!